Hello dear students, welcome back to our YouTube channel. We are studying about integral transform, and in previous lecture we have started our new chapter, that is Laplace transform, in which we have studied about the piecewise continuity of function, and we know that if we have an interval AB, then a function f of x is said to be piecewise continuous if every subinterval of AB, f of x is continuous in every subinterval of AB, and at every subinterval left and right hand limit is finite. Then we can say that the function is piecewise continuous. We have seen the example in which we have drawn the graph and we see the continuity of function in different intervals. Function is continuous in this interval, then again this interval, but it has different left hand and right hand limits, but both are finite. So such type of function is called piecewise continuous continuity of a function. Now today we will start with function of exponential order. Function of exponential order. If f of x be any function, f of x be any function is said to be function of exponential order. Function of exponential order if limit x tends to infinity e raised to minus x f of x is finite quantity. Limit x tends to infinity e raised to minus ax f of x is equal to finite number, then we can say that the function f of x is of exponential order. Here we are studying about the function of exponential order, and we are about to know the definition of function of exponential order, and in which the definition we have f of x be any function is said to be function of exponential order if limit x tends to infinity e raised to minus ax into that function f of x, and if we solve this limit and if we will get finite number, then such type of function is called function of exponential order. Take some example based on this definition, and definitely it will provide some basic idea about the exponential order function. So if f of x is equal to x raised to n, then f of x is function of exponential order or not. We have a function f of x x is equals to x raised to n. Then they are asking us f of x is function of exponential order or not. We have to prove the function is exponential order or not. Since we know that, since by definition of function of exponential order, that is limit x tends to infinity e raised to minus ax f of x should be finite number. Correct? So let's consider this left hand side. Limit x tends to infinity e raised to minus ax f of x, and since f of x is given as x raised to n, so we can write it as limit x tends to infinity e raised to ax into x raised to n. And if we want to write in simple form, so we will get x raised to n upon e raised to ax. Correct? What we have done here, we have f of x as x raised to n, and they are asking us to prove that the function is exponential or not, exponential order or not. So by using the definition of function of exponential order, we replace, we have the definition limit x tends to infinity e raised to ax dot f of x is equal to finite number, any finite number. Correct? Since f of x is given, which is x raised to n, so if we take limit x tends to infinity e raised to minus ax into x raised to n, so we can write this equation as limit x tends to infinity x raised to n upon e raised to ax. And if we put the value of x, if we put limit of x in this expression, we will get infinity upon infinity, and it is indeterminate form of function. So we can solve this type of example by using L'Hopital rule, and we know that whenever we come across infinity upon infinity form, we use L'Hopital rule, and in which what we did, we find derivative of both numerator and denominator. Correct? So we will take the differentiation of numerator and denominator separately. We will get limit x tends to infinity n x raised to n minus 1 and a e raised to ax. Correct? After differentiating x raised to n, we will get n into x raised to n minus 1. Similarly, if we differentiate e raised to ax, we will get a into e raised to ax. Since differentiation of x raised to n is equal to n into x raised to n minus 1, and since differentiation of e raised to ax is equal to a into e raised to ax. Correct? Now, if we put the limit of x in this expression, again we will get infinity upon infinity. Again, using L'Hopital rule, we will get limit x tends to infinity n minus 1 x raised to n minus 2 and a square e raised to ax. Similarly, in this manner, if we go again infinity upon infinity, so differentiating n times, we will get limit x tends to infinity n factorial a raised to n e raised to ax, and after putting the limit of this x, we will get n factorial upon a raised to n and e raised to a into infinity, which will give us a raised to n into infinity, and if we simplify we will get 0, which is finite number. So we can say that f of x is equals to x raised to n is of exponential order. Is of exponential order. We have the definition that if a function f of x is a function is said to be exponential order if it satisfies this value. Limit x tends to infinity e raised to ax dot f of x is equals to finite number of value आना चाहिए वहाँ पर. So taking left hand side of this expression, and we know that f of x is given as x raised to n. So replacing f of x by x raised to n, we will get limit x tends to infinity e raised to minus ax into x raised to n, and limit x tends to infinity, if we simplify this we will get x raised to n upon e raised to ax, and which is equals to infinity upon infinity. And if such type of indeterminate form occurs, when we will use L'Hopital rule to solve such type of expression, and in L'Hopital rule we differentiate numerator and denominator respectively and separately. So after differentiating n times we get n factorial upon a raised to n e raised to ax, and putting the limit of x, that is infinity, we replace this expression as n factorial upon a raised to n into infinity, and any positive number or any number divided by infinity will give us 0. So it becomes finite number. That's why x raised to n is a exponential order function. Now in next lecture we will see some more example depends on exponential order. Till then, thank you. Bye.